We're going to take a look at worksheet number 4, questions 4 and 6 right now. Number 4 says, a 400 kilogram bomb sitting at rest on a table explodes into 3 pieces. One piece goes off to the east, one piece goes off at 30 degrees south of west, and one piece goes off somewhere. That's what we want to find, where it goes and what the velocity, what the speed of that third piece is. Okay, first thing we want to do for this is draw a picture. This is a two-dimensional problem, an x and y component problem. We know every time we see south and west, or north and east, or west and north, whenever we see two directions that are on different axes, we know we have to turn it into an x and y component problem. And whenever we do one of those x and y component problems, we want to draw a picture. Does that make sense? So let's do that. Let's draw that picture now. Here's my explosion point. We have a piece that's going off to the east. I'm going to call that piece number 1. Its mass is 150 kilograms. Its velocity is 150 meters per second. There's another piece that's going at 30 degrees south of west. There's my 30 degrees, measured from the west, but south from the west. Its mass is 100 kilograms, and its speed is 200 meters per second. There is a third piece. Where is it going to go? Let's make an educated guess as to where this third piece is going to go. Up and to the left. We know for sure that that third piece is going to go up because we have a piece going down. Could go left, could go right, depending upon which x component here, 1 or 2, is bigger. But you know what, in the end, if we guess the location of the third piece incorrectly, it's not the end of the world. We have to get 1 and 2 correct. We have to draw that right. But the third piece, it's really just meant to help us visualize it. It's not the end of the world if we make a mistake with that third piece, since that's what we're trying to solve for anyways. Okay. What next? What next? It's staring you right in the face. What next? What do we do next here? Zach, what do we do next? Yeah, of this 200 meters per second, we got a funny angle, and we don't like funny angles. Every time you see an angle of 30 degrees or any other angle, break it into x and y, every time. Okay, the very first thing that we see on our always list over here on the board is we see angles, say we don't like funny angles, and deal with them. Let's take it off to the side, over here. Label it as 200 meters per second. Now what I like to do is label my x and y in a different color. If you don't have different colors, then whatever, it's not the end of the world, but I think it kind of helps us keep it organized if we have a different color there. Solve for x. X is the adjacent side, so it's cosine 30 degrees equal to x over 200. X ends up being 173.205. In the y component, we use the sine function. It works out to be 100. And now I like to kind of just block this off to remind me that it's important, but this is really like the only thing that makes this question different than one of those T-bone collision questions. So everything that's not boxed off is going to be the same for every question we do. The part that's boxed off is just what we had to do in addition to that. X components, Y components. How come? Because we have two dimensions. We have south and west. We have an angle. It has to be X and Y. Now, if we were doing something with kinetic energy here, then we wouldn't do X and Y. How come? Because kinetic energy is a scalar. But since momentum is a vector, and there is an X and a Y, we have to do X and Y. Okay, my X component, I'm going to say Pi equals Pf. I'm going to say, how come I said 0? Is that rest, right? 0, initial momentum is 0, m1 v1f plus m2 v2f plus m3 v3f. Usually, or at least most of the questions that we've done so far have involved 2 objects, not 3. But if we have 3, it's okay. We just have 3 terms. If it broke apart into 14 pieces, we'd go all the way up to m14 v14f. Pretty sure that's not going to happen for us, but okay, if we have 3 or 4 pieces, it's not a big deal. Why do I always say, like, man, I wish these masses were the same? Because then we could cancel them, right? Can't cancel them here, though. Mass 1 is 150. What's V1F? No, V1F is 150. Mass 2 is 100. V2F is, you know what I should have done over here? I should have erased this. That's what I should have done. And replaced it with 173.205 and 100. Tell me what V2F is. What is it? Good, negative 173. That make sense? Remember that 200 meters per second is gone now. Like we're never going to use that again. We replaced it with a 173 and 100. So don't try to use it here. Like X and Y components, don't ever use the hypotenuse in your X and Y components, ever. Just use it to get an X and Y component. Okay, plus M3 is going to be 150, okay, because it's 400 minus 150 minus 100 times V3F. Solve for V3F here. We end up getting negative 34.53 meters per second. I'm going to assume that you can rearrange that to get 34.53 meters per second. You should try it either now or later to make sure that you can do the algebra to get that number. And if you can't, you should ask me about it. Because it doesn't matter, like it doesn't matter, you can know what to do all you want. If you end up rearranging it wrong, it's wrong. Like it's still a 0 out of 1 on Thursday, on test day. Make sure you can do the algebra there. Now we do the y components. Pi is equal to Pf 0 again, because it's not moving on the y-axis either, equals m1 v1f plus m2 v2f plus m3 v3f plus m77 v77f if there was 77 pieces. 0 is equal to m1 150 v1f 0. Who said that? Good. This is 0. How come? Yeah, it's going to the east. Right? East is on the x-axis. What are we trying to solve for here? The y-axis. So how much of that 150 is on the y-axis? None. M2 is 100 times, we're going to say it's negative 100. Right? That 200 meters per second is gone, right? We replace that 200 with 173 and 100. Plus M3 times V3F. Solve for V3F here. And it works out to be, for the y component, 66.667. And then what do we do? Now's the physics 20 thing, right? Now's the easy part. Just combine them. We have negative 34.53 to the left. We have 66 upwards on the y-axis. Hey, by the way, did we guess right? We thought it was going to be up and to the left. Is it? Sure it is. 34 to the left and 66 up. Solve for v here using the Pythagorean theorem. and it works out to be 75.1 meters per second. Now we calculate the angle here as well using the inverse tan function, and it worked out to be 62.6 degrees north of west. Is that okay? What makes this question different than the T-bone questions? Just this little bit over here that's boxed off. Otherwise, it's exactly the same, right? PF, x component, y component. As soon as you see south and west in the same problem, or you see an angle, x and y components. Okay, simple as that. And if you see that angle, that funny angle, hey, again, we go over here to our list of always things. I don't like funny angles. Take it off to the side and get rid of it. Now let's take a look at number 6. A little bit different than we saw with number 4. We got a 200 kilogram bomb moving at a velocity of 10 meters per second to the west, exploding. Okay, I'm going to circle that in red because most of the explosion questions we see have an initial momentum of 0. This one doesn't. So I'm drawing attention to that. A, because the initial momentum is not 0, and B, because it's hard to really show that in my picture. I got to draw attention to it somehow. Explodes into 3 pieces, and they go off in various directions. Here's my explosion point. We have one piece, we'll call it piece number 1, going off with a velocity of 10 meters per second, 200 kilograms. No, that's not right. No, that's before, right? Afterwards, we got 100 kilograms going off at 90 meters per second. That's piece number 1. Piece number 2 is going north of east, 55 kilograms, 55 meters per second, at an angle of 30 degrees. The third piece, I don't know, I think it's going to go down here somewhere. I know it's going down, left to right, probably right. Not really sure. What's the first thing that you see? What's the first thing that you see? Huh? Leah? What is it? We don't like funny angles, so we take it off to the side before we do anything else, and we get rid of it. Degrees there. I'm going to draw that green again, x and y. And when you do the trig there, x works out to be 47.6314, and y works out to be 27.5. I'm going to box it off. So it's the same as we always do, right? There's value in structure. There really is. Like, we got to be able to think and think outside the box too. But having a certain structure for things kind of frees our mind or clears our mind to be able to think when we really have to think, right? So what I'm going to do now, you can choose to do this or not. I'm going to redraw this like this. My x is 47. My y is 27.5. And that 55 meters per second is gone now. Like we're never going to look at that again. And now it's just like question number 4 was. Almost, not quite, almost. Zero is equal to m1 v1f plus m2 v2f plus m3 v3f. Is that right? Somebody said no? Yeah, this isn't 0, right? This is m total times V initial. It's moving, right? It's moving before the explosion takes place. The total mass here is, what is it? 200, yeah. 200 times, we're going to say negative 10, moving to the left. M1 is 100 times 90, is that right? Negative 90, good. It's a big number for meters per second, right? It is meters per second, but if it was kilometers per hour, would it make any difference? You can convert to meters per second if you want. Do you have to? Not in conservation of momentum problems. You can keep it in kilometers per hour because the units cancel. M2 is 55 times V2F. Zach, what's V2F there?
47.
Yep, good. Yep, good. 47.6314, good. Plus M3 is, what is that, 35? 45? It's 45? 200 minus 100 minus 55. That works out to be 97.3394. Then we do our y component. What's my initial y momentum? 0, good. It's 0. How come it's not 200 times negative 10? Yeah, it's traveling to the west, and we're looking for the y-axis now, right? West is x-axis. So 0 is equal to m1 v1f plus m2 v2f plus m3 v3f. The y component is easier here, right? What else makes it easier besides the initial momentum being 0? m1 v1f is also 0 because it's all on the x-axis as well. m2 is 55. 55 times, pulling out the green pen here, 55 times 27.5. Positive because it's upwards. Good. Plus 45 times V3F, solve for V3F. And we do that for the y-axis. It works out to be negative 33.6111. Hey, we guessed it was going to go right and down. Did we guess right? Did we guess correctly? Yeah. Yeah, we did, because we got a positive number for x and we got a negative number for y. So let's redraw that. Let's say 97.3394, 33.611 downwards. And we could solve for v there using the Pythagorean theorem again. 103. And theta is 19.0 degrees south of east. When I skip a step here of algebra or trigonometry, okay, if you can't, make sure you try that if you didn't get it already. Okay, make sure that you try it. And if you can't get it, then let me know. You can look through this all you want and say, oh, you know what, I completely get what he just did. But if you can't do the algebra, it doesn't matter. 0 to 1. Which on your unit test is like 4 or 5%, right? Just because you didn't know how to rearrange, just because you didn't go home and try it.